Let's make some observations about how the derivative is related to the original function here. So f prime of x versus f of x. This first one here says that f prime of x is positive. That means that f of x is increasing. Well, first of all, to understand that, an increasing function looks like this. So the idea is that if I've got x1 here and x2 over here, that as x moves from left to right, that the y values, y1 and y2, it increases, right? So as x is going left to right, y is getting bigger and bigger. Well, any place on here, if I were to draw the tangent line, the slope of this is going to be greater than 0. So whenever the slope is positive, we know that the original function has to be increasing. The other way is to have a function that's decreasing. Right? So in this case, if I go look at this, the same way, I've got x1 and x2, they correspond now to y1 up here and y2 down here. So as x is, as we look at x moving from left to right, what's happening to the y values is that they're going down. So we say the function is decreasing as x is, is moving from left to right. Well, again, if I take a look at the tangent line at any point in that decreasing section of the graph, the slope of this line is going to be less than 0. So if the derivative is negative, then I know that the function is decreasing. And then the last one here says that if the derivative is 0, then the function is constant. This is what we've been looking at in the last couple of videos. I'm not going to spend too much time drawing that one right now, but it's just this idea that if the slope is 0, you're at a point in the graph where it's not increasing or decreasing; it's constant at that x value. This is going to lead us to what's called the first derivative test. So the idea here is pretty straightforward. You've got all this information. You can write it down, read it in a book, whatever. Essentially, we're just looking at the change in the derivative. Is it switching from positive to negative or negative to positive? And that's going to tell us whether our critical numbers correspond to a minimum value or maximum value. So remember from what we talked about before, we said that critical numbers are they happen when the derivative is equal to 0, right? And we said that all relative extrema, they have to happen at critical numbers. Well, the one piece we don't know, though, is which kind of an extrema is it? Is it a minimum value or is it a maximum value? And the way that we can tell is we do this first derivative test. So there are really only 4 possibilities for the way the graphs can come out. On one hand, you've got a relative maximum. So here's our critical number. So I've got this value c that corresponds to this point where the derivative is 0. If I take a look at the derivative to the left and to the right of c, I can see that over here, my derivative is greater than 0. And over here, my derivative is less than 0. And so we're saying that if at c, so everything that I'm thinking of is moving across the graph this direction. If it switches from positive to negative at c, so I make that switch, I know that I've got a maximum at my critical number. Take a look at another example. This one, of course, is going to be a minimum. So I've got the same idea. I've got this point where my tangent line has a slope of 0. So f prime of x equals 0. This is my point C. And I take a look at the derivative over here. if I draw this tangent line in, this derivative is less than 0, right? Negative value coming down there. If I take a look at the derivative over here, it would be positive, where the graph is increasing. So for this one, if I split this again at C, I see that it's negative over here and it's positive over here. It actually switches from negative to positive at C. Well, if it switches from negative to positive, then we say that's a minimum value. That's what's going on in these two statements here of the first derivative test. We're saying that if we look at this derivative and we see that it switches from positive to negative at a point C, then that C must be a relative maximum. If we look at the same derivative, we see that it switches, like this case, from negative to positive at that point C, then we know that f of C is a relative minimum. If it doesn't change, there are, we'll look at just two different drawings of where it wouldn't change. If I've got a graph like this, or a graph like this, in both of these, I do have a point where the derivative is 0, right? I have a critical number. Same thing here. Tangent line in here. This corresponds to my critical number. But when I look at the derivatives at the places surrounding C, here I've got f prime of x is less than 0. And here, f prime of x is less than 0. So on either side of C, this one's going from negative to negative, right? So as we go across, it doesn't change. And I have no maximum or minimum at that point. Same thing over here. Let's do this one real quick. Two tangent lines, both of them are positive. So at C, we're going from positive to positive. As we go across C, there is no change. So it's neither one. It's not a maximum or a minimum. That's what's being addressed here by this last one. So the last thing we're talking about. If f prime of x doesn't change at C, then f of C is neither one. It's not a maximum or a minimum.